All right, hi again. This is Josh, and welcome to JW2542 Tutoring. Again, the SHSAT math class, free online this year. This is the course that I've been developing personally for over 9 years here in New York City, and I did attend the Bronx High School of Science and graduated in 4 years with a Regents diploma, as well as BC Calculus and some work on the math team. I majored in mathematics and Jewish studies in college and did a graduate degree in math education at Columbia Teachers College. This is a Venmo course, meaning you can pay by donation. The recommended donation is $50 per lesson, which is less than as it's offered at tutoring houses in New York City. You can donate anything you like, whatever you think the course is worth. And I have on Venmo here. I'm giving this back as a gift to the community, as I did pay for college from donations as well as a street performer, a musician, and circus performer by donation, or most of my earnings. So thank you so much. So here's my SHSAT 7th grade course. We're going to begin in just a moment. Today, the core lesson is we're going to focus on using algebra for word problems. Just lesson number 11 of 25 lessons I'll be sharing this school year. The SHSAT standardized test is a math and ELA exam. The mathematics section focuses on middle school knowledge of topics such as algebra, geometry, coordinate planes, charts and graphs, probability and statistics, and a few other math topics. These topics include sort of problem-solving puzzles that deepen your understanding of the number line, as well as consecutive number patterns within the operations of mathematics, as number patterns, as well as other logic puzzles. In its current form, the SHSAT math section is still 75 minutes, half of the exam, and ELA is also 75 minutes for a total of 150 minutes. 57 questions total, 5 grading questions, as well as 52 multiple choice. The SHSAT lesson number 11 will focus on algebra word problems today. So I have a few model problems, again, just like the worksheets in my course, with easy level, mid-level, and challenge level examples for this exam. Working with a prep course for standardized tests is a very, very good way for students to stay organized, get confident, gain self-esteem, and perform better on test day. This course is 33 lessons, of which I'm sharing 25 of them. In its current form, I've been personally developing this class for over 9 years, revising each lesson one at a time at the end of each semester, sitting and reviewing all of the content to improve it year after year for children preparing for the SHSAT math exam. You can see here that on the top banner, JW2542 Tutoring, we're going to begin with this lesson soon. But first, just like at the tutoring house, we always warm up and welcome students with a quiz. The daily quiz has 4 multiple choice questions and 1 challenge level question. All of the sample quizzes for this tutoring course that I personally wrote begin with 2 easy level warm-up questions, then 2 mid-level, and end with 1 challenge level grid-in question. So students can track their own progress as they hold on to their quiz results. They can see their consistency improve in easy level questions, then move on to working harder on the mid-level problems, figuring out which steps are difficult for themselves, and then approach the challenge level problems. With this sort of pedagogical scaffolding, students can gain confidence. They can work with peers. They can say, hey, I didn't get that step. How come you got number 4? I didn't get number 4. And they can also celebrate their successes as their scores improve on the daily exam. So I invite you to try SHSAT quiz number 11. This is of the set. It has 4 multiple choice and 1 challenge level. If you click on the blue link or cut and paste, there's the blue link there to a Google form. We'll go to my Columbia University Drive, and you can access the form. I'll be leaving this link open share for the entire class. in perpetuity, if, for heaven forbid, the prestigious Columbia University decides to change the links, I will add them to the comments below of this YouTube channel. But it's mine. I have it for a lifetime as being a graduate of Columbia Teachers College. All right, so it's mine. All right, anyway, yeah, so if they decide to change some of the coding, then we'll deal. Right. Okay, so then moving on. Yeah. Quiz number 11. I'm going to set a timer for 12 minutes as there are 3-word problems here. So good luck on SHSAT quiz number 11. I will mute. And if you're watching this recording on YouTube or on Twitch, you can fast forward to the 12 minutes and we'll continue with the review of these 5 questions. All right, good luck on SHSAT quiz number 11. Here we go. Good luck. Ta-da. Okay, please take a break from the problem that you're working on and make sure you can answer for all 5 questions. That's time for SHSAT quiz number 11. What we'll do now is just like we do in class, we'll go over step by step a solution to each of the problems presented in under 2 minutes. Here is question number 1, which reads, what is the greatest integer that's less than 43 upon 6? Well, we know that 43 over 6 equals 42 6 plus 1 6. This is a whole number. That's 42 divided by 6 is 7 plus a 6. So it's equivalent to 7 and 1 6. So read the English carefully. It says that they want the greatest integer that is less than that mixed number here, 43 upon 6. The correct answer was D, 7, for question number 1. Question number 2 reads, 3 consecutive even integers add up to 126. What's the largest number divided by 4? Well, here we have a shortcut that we can use from our knowledge of integers in a row. So let's say the middle number is x. Then the next even integer will be 2 greater. And the next integer after that will be another 2, so it'll be 4 units greater. Wherever we're at on the infinite number line, even numbers are spaced by 2. Well, also we know that the one that comes before whatever mystery number x is will be 2 less. For example, the numbers 10, 12, 14, 16 are all even numbers which skip by 2. But what we're looking for is we're looking for 3 numbers in a row which add up to 126. So we're going to cleverly use this set of 3 in a row. So if we add them together, we'll have x plus, we'll have x minus 2 is the first number. The middle number will be x. And the number that comes after that will be 2 greater. But if you look carefully, what's nice here is that -2 cancels +2. And then we have x plus x plus x, or 3x, equals our sum, 126. Divide by 3, and we get x equals 42. I'll bring that all the way back up to our placeholders here. That means that the middle number is 42. The number here is 40. And the number that comes after it is 44. And sure enough, 40, 80, 120, 0 plus 2 plus 4 is 126. And we've cracked the code. We found the location on the number line for those 3 consecutive integers. That's the set on our infinite number line. But the question was, what's the largest number divided by 4? So there's an extra step from this writer. We have to take 44 and divide it by 4. Well, that's 11. The correct answer was B, 11. All right, next question. Question number 3. What is the surface area of a rectangular prism box that is 8 inches by 5 inches by 2 inches? Well, here for this one, I'm going to bring out the little geometric annotator here. It's 8 by 5. We'll make that the front face. And then 2 inches deep. How about that? So it's sort of like this. Okay, so it's like a pencil box, but I have it upright. Okay, 8 units by 5 units by 2 units. And I'm connecting the 2 units with these little rods here. Okay, I'll actually label it in the design. That means this side is the 8 side. This side is the 2 side. And this side, the height, is the 5 side. I'll put it on the back post here. But what I'm saying is, I'm saying that the dimensions come from this cornerstone. Okay, what? Why is it dragging that? This is a new toolbar. There it is. Very nice. All right. So as you can see here, those are the dimensions of our box. But we want to shade in, we want to figure out the surface area if we were to paint it, or let's say we had the box and we were to like gift wrap it, right? So it's 8 by 5 by 2, and this is going to be our box that we're going to ship in. We're going to place an item inside the box. Here's the front wall. Well, the front wall is 8 units on the base and 5 units high. But so is the back wall, right? So that we get this idea, I'll shade it in two subtly different colors. So I'll shade in here in a double blue, and then in the back wall in a light blue. Can I do that? Yeah, so I'll use a darker blue for the front wall. Or should I use a darker blue for the back wall? Let's see what it looks like with the annotator. Can I use a dark blue? Is that understood? Now, no, that's playing tricks on my eyes, because then it makes the back wall want to be the front wall, so I'm not going to do that. I'm going to make the dark face the front wall, because then the front is darker, and that is less of a strange optical effect. All right, can everyone see that? So there's the front wall is in darker blue, and the back wall's in lighter blue. All right, that's much nicer. But we can see that if we were to unfold the box, like if I took this box and I folded forward that front blue face, it would look like that. Then the bottom face would be 8 by 2. So it's 8 long, but it's not 5 high. So that would be the bottom of the box. Then I would have to go back to the back face, which having the lighter color. So I'm going to fold it, would fold the flap down that way. But then the top of the box would be, I'll draw it another color, would be 5 by 2. Wait, can we even do that? No, the top would also be 5 by 2. Yeah, so I have to make it thin, just like the bottom. I'll move it up. Okay, can you get out of the way? Yeah. All right, and then the left and right faces will be, I'll make little yellow frames so that it makes sense. I'm going to just fold it from the side here. I guess then I'm using the back side. Sorry, yeah, it should be like this. And like this. So maybe I should erase this one. And I think it's tradition to make the top the bottom, which is a weird idea, but that would make more sense. Sorry, hold on a second. It's taking more than 2 minutes to draw this. There. I'm gonna actually write in the words what's going on here. All right. There's the white chalk. This is the bottom face. It's down there. That's the bottom of the box. This is the front. This is the back. Unfolded. This then is the top, because if we go bottom, front, this is the top face up down here at the bottom. This is the left flap. And this is the right flap. So I'm taking time to do this because it's 7th grade and you should be familiar with surface area. Here, I will draw it with yellow arrow so you can see that. I'm pointing to that's the right face and that's the left face, okay? And there's the 2D drawing of our 3-dimensional box. In other words, as I promised, I was going to use the highlight with the rods here. These rods are now drawn in yellow, so you get the idea of the rectangle of surface area that's being painted. That would be, you'd have to paint within that yellow frame. Okay, so that's the surface area of the left and right walls to be painted. So we're gonna paint. I'm sorry, I keep saying paint, but we're doing gift wrap. So it's gonna be how much gift wrapping paper do we need? How many square inches? So the front face is 8 by 5. 8 times 5 is 40. So that's the surface area in square inches of the front face. 40. Okay, so that's the front face. 8 times 5. Well, it's also the back. So the back is also 40. Then the bottom is along here. It's 8 by 2. And 8 times 2 is 16. So that means that the bottom is 16 units. But the bottom has the same dimensions as the top. So the top is also 16 units. The left face is 5 units tall and by 2 units deep. So that's 10 units. And so is the right side. It's also 5 by 2 is 10. So here is our quick map of all of the surface area of all 6 sides. So front and back is 40 each. So that's 40. And then top and bottom. Well, those are 10 each. So that they're each, 16 each. And then left and right are 10 each. So that's a total of 66. But we have to times that by 2 because we're counting 2 at a time. And that was 132 square inches of wrapping paper. So the correct answer would be A. The surface area, or the amount of paper to wrap the box, is 132 inches squared. Let's go to question number 4. All right, it took so long. I should have preset the geometric net. Anne can type 45 words per minute. Betty can type 80 words per minute. If one page of book contains 500 words, how many more complete pages can Betty type in an hour? There's a faster way of doing this. We have Betty is at 80 words per minute. And then we have Anne. Very good worker as well, but 45 words per minute when she's typing. Let's find the difference. So the difference is 80 minus 45. 8 is bigger than 0. 5 is bigger than 0, so make this a 7. Change this to a 10. 35 words per minute. How many minutes are in an hour? Because we're wanting to know how much more work can Betty then do in an hour. So we have to do 35 times 60 minutes. 0. 65 is 30, carry 3. 2,100 words. She can type 2,100 extra words, but it's 500 per page, so we have to divide that by 500 per page. Faster way to do this is let's do times 2 and times 2 on the bottom, and then we get 4,200 over 1,000. Cross off, cross off. Wait, cross off, cross off. And we get 4.2 pages more, right? Because it's 42 over 10, or 4.2 over 1. So all I'm doing there on the bottom, if that's new math for you, is just make sure if you move the decimal 1, 2, 3 to the left, 1, 2, 3 to the left, then that's equal to 4.2 over 1, which is anything over 1 is itself. Okay. So just move it the same number of decimal places to get that 1,000 and scale down to 1. All right, and the correct answer was C. Betty can type a little more than 4 extra pages if she works. And they both type. So Betty has a very exceptional typing skill, and she can get 4 more pages done if she sits for an hour and types. Last one for today. Question 5. There are 5 lions for every 9 bears and 3 tigers for every 7 lions. How many bears are there if there are 20 tigers? Lions and tigers and bears, oh my. Well, I wrote it. Here we go. Lions, tigers, bears, because it's from an old American movie. Look it up if you haven't heard. Lions and tigers and bears, oh my. Lions and tigers and bears, oh my. What happened to the lion, oh my. Lions and tigers and bears, oh my. I'm going to put up little cages for these fun facts. Lions and tigers and bears. Fact 1, we'll put up some cages. And fact number 2 ratio. And then figure out the true ratio between all 3. So fact number 1, there are 7 lions. So those are our 2 facts. So what can we say here? Well, 5 and 7 are different numbers. So we can't just say that there are like 12 lions for every 3 plus something bears. And no, we have to scale them up so that we have the least common multiple in the front row. 5 times 7 is 35, right? But to make 35, what we have to do is, be careful, you have to do times 7 for the first row. So lions times 7, but also since it's a ratio, we have to do bears times 7, because for every 5 lions, there are 9 bears, meaning for every 35 lions, there are 63 bears. And then 7 times 5 for the second ratio. So note that this is a different multiplier. So we have to do times 5 for the second row. Then we have the true ratio. And I'll write that in just a moment. We have 5 times 3 means that 15 tigers. And as I mentioned, 7 times 9 is 63 bears. So here there are lots of bears. There's more bears than lions and tigers put together. But the question was, how many bears are there if there are 20 tigers? Well, this is a little tricky. But if you look at the numbers as they were scaled, it's convenient that they're both on the 3 times table because, well, that's because 3 and 9 were both on the 3 times table. But what we're going to do is we're going to do a math skill. We're going to divide each of these by 5 now. Then we get that for every 5, 15 divided by 5 is 3 tigers. There's, wait, that doesn't work. What did I say? They're on the 3 times, so we have to divide by 3 because they're both divisible by 3. Excuse me. So then 15 divided by 3 is 5, and 63 divided by 3 is 21. So we can scale down to the 5 times table and to 21 times table. 5 to 21 is the same ratio. But there aren't 5 tigers. There are 20 tigers. So last step, we have to multiply it by 4. So then 5 times 4 is 20. And the correct answer was, for every 20 tigers, there were 84 bears. The correct answer was 84. The end. That was question 5. Doesn't work out so well for the lions because the lions aren't divisible by 3. All right, but the tigers and bears, very good. Okay. All right, let's go to today's core lesson. We're going to look at SHSAT using algebra for word problems. So our focus today is on word problems and puzzles. And you'll note that a lot of it is math that you've done in school and middle school, if you're a middle school student, or if you're a teacher or a parent working with a child right now, you'll notice that there are more puzzle-solving problems. So be careful, be a careful reader, and stay organized. And you too can take the keywords and translate them into the language of math. Here we go. I'm using algebra for word problems. Excuse me. An equation is a mathematical sentence that contains an equal sign. An algebraic equation may contain one or more variables. You may need to translate a paragraph into an algebraic equation to solve a word problem. Then use PEMDAS and inverse operations to solve the equation. Let's go to the next slide. First example. Below are 4 examples of problems of SHSAT algebraic word problems. Problem 1. Mary has 37 coins in her coin collection. That's 14 more than her brother Charlie has in his collection. Write and solve an equation for the number of coins that Charlie has. Here's the solution. Identify the keywords to translate this paragraph into an equation. The word is represents the equal sign. The words more than represent the addition sign. Mary has 37 coins, which is 14 more than her brother Charlie. So M for Mary is equal to 14 plus Charlie's collection. Subtract 14 from both sides once you have the equation set up. And Charlie has 23 coins. The correct answer is 23. Problem number 2. The school art teacher has 6 packages of brushes and then also 8 single brushes. Each package has the same number of brushes. In all, he has 80 brushes for his students to use. How many brushes are in a package? Well, X represents the number of brushes in a package. So what I mean here is that if we were to draw it, here's like an art table. If you had like a cylinder with some brushes inside, there's 8 inside that bucket of brushes. But then he has like a package from the store, and inside each package, there's X number of brushes when he goes and buys them at the store. Well, he has 6 of these packages with X inside, plus 8 already on the table, and that equals 80 brushes that he needs for class. Subtract 8 from both sides, we get 6x equals 72, just like above. Then dividing by 6, or if you don't have a calculator, divide by 2, 3x equals 36. Now divide by 3, and x equals 12. Meaning that contained inside each of these containers that you buy at the store, there would be 12 brushes or a dozen brushes in each package. The correct answer was 12. All right, I think drawing it made it super easy for the 6th and 7th graders. Number 3, Cole is 3 times as old as Marty and Beatrice's ages combined. If Cole is 63 and Marty is 12, how old is Beatrice? Well, just stay organized because there's 3 people here that we're concerned about. And I'll highlight it here as we follow along what's being spoken. Okay. How old is Beatrice? Well, Cole is 3 times as old, so there's 3 times. And then we have to take Marty and Beatrice and add them together. 3 times if we add them together. Did everyone see that? But then we are told Cole's age and Marty's age. That makes the problem a lot easier. So we're going to drop in that knowledge from the paragraph. You just find those details. Cole was 63. There it is. Marty, M for Marty. Marty was 12. Now the numbers are plugged in properly. 63 equals 3 times 12 plus B. Then we can distribute the 3. 63 equals 36 plus 3B. And subtracting 36 from both sides, 27 equals 3 times Beatrice's age, and Beatrice was simply 9-year-old young lady, 9-year-old girl. All right, there might be an easier way to do this. Here, I'll draw it on the page. At this step, we could probably just divide by 3 here, and that would make the math easier. Then we just have single-digit numbers, I think. Or anyway, the numbers will be scaled down. So if you made a mistake and you didn't get the right answer, at this step, you could divide by 3. We could say 21 equals 12 plus B. Then it's much easier. You don't have to distribute, right? So if you divide by 3 on that side too, okay? Yeah, I should show that as well. That's a good shortcut because then you just subtract 12 from both sides. 12s cancel, and Beatrice is 9. Okay, cross this one off, make it a 1, make 11 minus 2 is 9. 1 minus 1 is 0. We're good. Okay. All right, that's problem 3. Problem number 4. Wait. Last one of this increasing difficulty. All right. Yosef, it's like the Middle Eastern pronunciation of Joseph. Yosef or Yusef. Yosef. Depends on the country. Yosef earns $15 per hour working as a carpenter's assistant. So that's his normal take-home pay. However, after 40 hours, he earns overtime pay, an extra 50% per hour. So here comes his calculation for his overtime pay. Yosef worked a total of 65 hours last week. What was Yosef's total pay for the week? All right, so he worked more than 40 hours. But first, we calculate his pay for the first 40 hours. It's $15 an hour. So if he works 40 hours, that's the first 40 hours. He'll get $15 an hour. Okay, so that's $600 of pay right there for the 40 hours. But then 65 minus 40 is 25 extra hours. And according to American laws, union laws, which is an amazing thing about America, he will make an additional 50% pay. Because so that we can't exploit workers in our factories. No matter how much we need to produce and how much we want to make, we don't want to abuse our workers. So the extra hours is 25. That means that needs to go into the 65 minus 40 will be the extra 25. And the new rate will be every hour after 40 hours. So like, come on, we're short workers. We don't have that many workers. We need you to say, I will pay more. They'll pay him $22.50 an hour. Aha. So those are an extra 25 hours. So $22.50 times 25 works out to be an amazing $262.50. So for 40 hours, he gets $600. Right? We have that here. We already calculated that. But he's working 25 extra hours. So believe it or not, according to the laws in America, you get extra pay if you do that. Any extra time that you're working in your life. So that's almost doubles his paycheck. 600 plus 5, 62.50 gives him over $1,000 in 1 week's pay as a carpenter's assistant. Maybe I'm in the wrong line of work. Maybe I make more money if I have regular pay and overtime pay. Imagine if I were paid for writing this lesson and doing all the PowerPoints and stuff as well. Boy, then I could afford to do other things with my life and really enjoy life. Wow. All right, let's keep going. Okay, so now those were examples of increasing difficulty. Number 4 was the most difficult that it is on the SHSAT. So here's my lesson number 11. And what you're going to see is you'll see 30 practice questions. The first 12 are easy level, the next 6 mid-level, and the last 6 challenge level. And they're followed by 6 gridding questions of increasing difficulty, 2 from each level. So please enjoy SHSAT classwork number 11, 30 questions. Here's the Google form link. And because it's an odd numbered lesson, only work on the odd number problems, which we'll review after a 20 minutes free practice. If you're watching this video on Twitch or on YouTube, remember you can fast forward 20 minutes and see our review. I'll just select one or two from the easy level tier, the mid-level tier, and the challenge level tier, unless a student chimes in the chat window of one that she or he would like to go over. All right, so anyway, good luck with SHSAT lesson number 11, and I will see you in 20 minutes. All right, ladies and gentlemen, please take a break from the problem that you're working on. And that is all the time we have for SHSAT classwork number 11, odd problems only. Excuse me. And as I reload the slideshow, we will get back to the core lesson in just a moment. All right. So as you can see here, we have the solutions to SHSAT classwork number 11 using algebra for word problems, written by me, designed by me, produced by me, and completed by me. Classwork number 11 using algebra for word problems. Here we go with the answers. Enjoy. Number 1 was C. Number 2 was C. Number 3 was A. Number 4 was E. Number 5, C. Number 6, D. Number 7A, 8C, 9B, 10C, 11C, 12E, 13D, 14C, 15D, 16D, 17D, 18E. 19 was C, 20 was B, 21 D, 22 was C, 23 was D, and 24 was E. 25 was 27, 26 was 11, 27 was 84, 28 was 85, 29 was, no, 29 was 3 ice cream bars. That should be 3. And 30 was 540. Let me fix number 29 right now. Should be 3 granola bars. Wait, let me check that problem. How many ice cream cones could she buy? Yeah, each ice cream cone is worth 3 granola bars. So the correct answer is 3, not 9. I don't know why it says 9. That's not it. All right. Duh. All right. Going back to the core lesson. Let's go now and finish up with one easy 1 minute, 1 challenge level problem. Thank you for checking out my class. And let us begin with question number 3. Selling books, paperbacks and textbooks. It's fun. It's fun selling books, whether they're school books, comic books. Found some comic books from Nancy Reagan and Nursing Out a Drug comic books that I have in my collection. All these years, I could not believe it. Just sitting there the entire time. It was in my possession. Anyway, number 3, let's go. Let's work. A book sale charges 50 cents per paperback and $1.50 for each hardcover book it sells. Additionally, used textbooks are $2 each. How much more does it cost for 12 paperbacks, 6 hardcover books, and 6 used textbooks total? A bit of a wordy problem. Maybe it should be mid-level, but just keep it organized. If you've gone shopping with mom and dad, shouldn't be a problem at all. No problem. All right, here we go. Let me explain. Dun, 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 dun. All right, so we have 3 different items on sale: paperbacks, hardcover, and textbooks. So do them as separate orders. So let's see. Paperbacks are 50 cents. Hardcovers are $1.50. Let's put up the nice US dollar symbol. And $2 for a textbook. All right, what do we know? We're gonna do for the paperbacks, we're gonna do times 12. For the hardcovers, times 7. And for the used textbooks, times 6. So they are in order. All right, 50 cents 12 times, that's $6 for the paperbacks, right? You just have to do them one at a time. Just keep it organized. Then the hardcovers a little more difficult because they're not buying 76 of them. They're buying 7. 7 times $1 is $7. And then 50 cents 7 times is $3.50. So you can do it like that way and you won't make an error. Then 2 times 6 is another $12. Everyone see what I did? No? Wow, let me cover that thingamajiggy-wiggy. The 6 should not be there. All I did was I used the idea of distribution, pivoting around the decimal. 7 times 1 would be $7 worth of items. Okay. So I'm just distributing. 7 times 1 is the $7. And then 50 cents at a time, right? 7 times 50 cents is an extra $3.50. So I know that it's $10.50, but I just did it by using right distribution. If you have not seen that before, often teachers in American schools, they skip that. 7 times that, and then 7 times the dollar amount, and 7 times the cent amount, just so I don't make any carry errors. I can do it a little faster. Okay, so that was the middle step. We have to add up all grand total for the entire deal. And we get, let's see, 7 times 3 is 10, 22, 28. $28.50. The correct answer was A. If you chose A, awesome. For question number 3. Let's go to a mid-level question. Odd questions only. It is lesson 11. Young Kyung's problem? No, it's easy level. Hi, Young Kyung. Willie? Word problem. No. 13, Mr. Barnum's problem. Ugh. This is not an easy one. Let's do Miss Tanuki. Yay, Tanuki. All right, so Miss Tanuki's class, there are twice as many boys as girls. Half the boys are in the math club. And all the girls are in the math club. B for boy, G for girls. Okay. There are twice as many boys present as girls. So if girls is X, then boys is 2X. But it said half of the boys. So we want half of 2X. Well, that's just X. And then for the girls, this is all the girls are like, yay, math. They all go to math club. Okay, so let's make a total column. So total in class is 2X plus X is 3X total. That's all of her students. We go across. But in the math club total, we have X plus X or 2X that are going to math club. This is half of the boys and all of the girls. What percent is that? Well, the number going to math club is 2X, and the population total is 3X. X's cancel, and it's 2/3, which is the same as B, 66 2/3%. Okay, that's a landmark fraction that you guys should know. Should know that. 2/3 is 63 2/3. Here, let me set up properly. The entire population, and then those who are going to math club are the 2X. Okay, so that was question number, question number 17. Okay. Any questions? D was correct. Bye, Tanuki, be well. Okay, next one, 19, going to challenge level, 21. 21 is clever. I like 21. 21 is coding. And it says, if A infinity sign B is A times B over A minus B, what is 3 infinity sign 2 equal to? Well, let's figure out first the given. This means that A equals 3 and B equals 2 is the plugin. Is just a fast way of coding it with the symbol for the rule here. Product over the difference. So then A times B will be 3 times 2. Longs in the numerator, you have to plug in both variables. And 3 minus 2 in the denominator, which would be 6 upon 1, which is 6. So we want to see what would be good is if we could figure out which of the ones A, B, C, D, and E. Following this rule, the product over the difference gives the same ratio of 6 units. All right, so here we go. Okay, precisely 6. So let's look at them one at a time. So I'm just going to use a yellow chalk because it appears up much nicer on the screen, and we're good. Okay, so for choice A, Well, we'll have 2 times 3 is 6 over -1, so it's not A. For B, we'll have 6 times 1 is 6 up on top, and the difference is 5. That's not a whole number. It's not B. For C, we'll have 6 times 2 is 12 in the numerator, and the denominator, that's 4. Ah, no, that's 3. So also incorrect. But for D, we have 6 times 3 is 18 in the numerator, and the difference is 3, and that's 6. So that's the right ratio. Let's just make sure E is not correct. 8 times 4 is 32 upon the difference. 8 minus 4 is 4 is 8. That's not equal to 6. So there's only one match. D was absolutely correct, ladies and gentlemen. 6 infinity sine 3 following this rule also has a ratio of 6, just like 3 in infinity sine 2. Interesting. Very, very, very well done. I'm impressed. All right. The end. Yeah. Well, we're going to do one or two more. Let me just dive a little deeper into this because this can help you understand like the way the puzzles are designed on these. If you like math team. This is in a ratio of 3 to 2, right? A and infinity sine B. So let's just dive a little bit deeper into this. So let's just pretend that this is 3A, and that's our A value, and this is 2A. Then when we multiply them together, 3 times some amount and 2 times some amount, the numerator will always be 6A squared. But then the denominator, since it's sort of in those ratios, will be 3A minus 2A, will always be A. So we will always get 6 times A. Here A is 1. In other words, A is 1. What's my point? In other words, let's look at this same idea of the ratios for D and E, because something kind of interesting happens. D is, following this logic, 6A times 3A would be the product, and then putting a variable with it, then 6A minus 3A, right? So it doesn't matter what A is, but then 6 times 3 is 18A squared, and 6A minus 3 is for 3A, so it'll be A will cancel, and we'll also get 6A. Because 18 divided by 3 will always be 6. So it does work out for D. Here's the weird part. What was I trying to say? Okay, here's the weird part. Can I say this right? Look at D and E. All right, what if instead I say that 6 is to 3 is the ratio, and 8 is to 4 is the ratio, is the same as 2x to x. So D and E are related in a different way, but you can deepen your understanding of the idea of this this ratio, this quotient. So then we'll have 2x and x. So then we'll have 2x is A, and x is B, and we're dividing ratio 2 to 1 are these values. So then the difference will be 2x minus x. What do we get? We have 2x squared over x. X cancels, and we get 2x. So that means that it depends on what x we choose, and then we're going to double it. This side is x, and this side will then be 2x. So let's see how that works. I'm going to put up a black card on the left, and we'll look at D and E, but just diving a little bit deeper into it with another variable. Let's say, no, go away. Let's say x equals 3 versus x equals 4. Well, if x equals 3, then we have 2x equals 6. If x equals 4, then 2x equals 8. Well, using the rule AB over A minus B, AB over A minus B, we get, okay, now we have 3 and 6. That will be our A and our B, because x is B. And then this would be A, conversely. Just going back to the theory of it. Okay, so then 6 times 3, this will be 8 times 4. I have it set up correctly. And then A minus B will be 6 minus 3. 18 upon 3 is 6. 8 times 4 over 8 minus 4 is 32 over 4 is 8. But wait a minute. We said that that's supposed to equal 2x. Well, 2x equals 2 times 4 is 8, and it does. 2x equals 2 times 3 is 6, and it does. Okay, so this is a very profound statement on the basic operations, the product and difference, and you can see that there are a lot of very amazing relationships depending on the ratios of the numbers that are chosen, even though it's the product and difference algorithms, because the way you can set it up as a ratio between A and B. All right, that's all for now. I'm gonna just food for thought if you're working on these ratio problems. Good introduction to high school and college math. All right, are we done? Odd questions, 23, 25, 27, 29. Should we end with Arlene? Yeah, because it was wrong on the key. Let me explain why I'm the math teacher. Haha. Number 29. Arlene has just enough money to buy 3 granola bars and 2 ice cream cones. Let's draw it. Here's granola bar, granola bar, granola bar, plus ice cream, is the same as granola, 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 9 granolas. Okay, so subtract 3 granolas from both sides. Just put it that way. Here are 3 granolas. We'll cross that off. I'll set off 3 granolas on this side. Then 2 ice cream cones definitely equals 2 ice cream cones equals 6 granola bars. So that means 1 ice cream cone must equal 3 granola bars. Okay. So how many ice cream cones can she buy? Well, wherever we see an image of 3 granola bars, that's 1 ice cream cone, 1 ice cream cone, 1 ice cream cone. In other words, 1, 2. Yeah, that could be traded in for an ice cream cone. It's worth 3 cones. See? So maybe drawing a picture is easier for this one. I don't know. You tell me. But that was question number 29. The answer is 3 ice cream cones Arlene could buy for the same amount of money. The end. All right, so what did I do here that might have helped you? Is I drew it for you. It's middle school math. So you can still use those skills. If you had a good teacher who added pictures or drew it for you to help you visualize, it's really good for 7th and 8th grade learners who are learning algebra. And then when you have the steps and you understand that idea of trading and balancing and rebalancing, you are in good shape for these puzzles and problems. All right, we need to stop for today. What I will do is I'll clear the screen. And thank you for joining me again for SHSAT classwork number 11. Using algebra for word problems. There are the solution sets. Everything's free online. It's all linked to my Columbia University drive that I received after graduation. And this is my tutoring website, JW2542 at wixsite.com. You can see that for over 15 years, I've worked with thousands of students to prepare for the standardized exams, such as the New York State Regents, the SHSAT, the test for Catholic schools, the cooperative exam, the high school placement test, the pre-SAT, the SAT, the ACT, AP exams in calculus, statistics, physics, as well as the graduate record exam for college students. My students have received scholarships to gifted and talented schools, acceptance letters, quarter, half, and full scholarships to Catholic school programs, scholarships for regions, as well as college programs, graduate school programs such as nursing and business and medical school. So I thank you for having me in your life as your tutor, as your math tutor, to help you get organized for whatever level test that you're getting ready for. I am a test prep specialist, so I have been, and as well as a specialist for one-on-one tutoring as a homework and a helper for students to level up their skills as they learn their mathematics. If you'd like to hire me, you can read more about me on my website, and I have hours available, and we can certainly work out a schedule online, which is best for me, so that I can help you achieve the results that you would like to achieve. So thank you. Finally, the links for this class are free online quiz number 11, classwork 11. There's a Google form link and homework number 11. And I hope to see you live on November 29th, 2023, as we return next Wednesday for SHSAT lesson number 12. Also, please remember you can donate to support this SHSAT course development at Venmo, Joshua Wiener 10. I'm constantly working on this class and the SAT class to bring you solid pedagogy, an excellent course that's offered as a free share by donation for your child, or if you have a family friend or relative who has a child who's getting ready for the SHSAT here in New York, or the Scholastic Achievement Test to add to their college portfolio. Thank you so much for watching this video. Take care, happy studying, and thanks. Hope to see you next time. Thank you. Bye-bye.